Good day everyone, I'm Arnold Iagawili Jr. And ang topic natin ngayon ay Operating Principle ng Solar Thermal System, also called CSP. Solar thermal power plants collect energy from the sun with the use of mirrors. The collected energy is being reflected or redirected to the tube. This causes the fluid to achieve high temperature. This fluid then transfer to heat to water, which become a superheated steam. This steam is then used to turn turbine in a power plant, and this mechanical energy is converted into electricity by a generator. Types of solar thermal systems, also called CSP: parabolic dots, solar tower, linear pressure reflector, parabolic dish.
So let's talk about the general description of the parabolic trough. So these trough, also known as a line focus collectors, are lined up in a rows on a solar field and are composed of a long parabolic shaped reflectors that concentrates incident sunlight on a pipe that run downs at the middle of the trough. So the collectors utilize a single-axis solar tracking system to track the sun across the sky as it moves from east to west to ensure that there is always maximum solar energy incident on the mirrors. So the receiver pipe in the center can reach temperatures upward of 500 degrees Celsius as the trough focuses sun at the 30 to 100 times in its normal intensity. So dito makikita natin ang example ng parabolic trough. So a parabolic trough is a type of concentrated solar power system, katulad nga ng sinabi kanina, na kung saan it is long and curved mirrors arranged in a line concentrate sunlight on pipes located at the mirror's focal center. So on the next slide, makikita natin dito na dito yung merong reflector, absorber tube, and also the solar field piping. So, dito sa mga next slide is mga pictures lang din ng parabolic trough. So, operating principle ng parabolic trough is, the first one is the heat from the sun is being collected by special mirrors, which is then reflected to the pipe that runs down in the middle of the trough. Next is, within this central pipe is a heat transfer fluid or the HTF flowing inside it. The HTF inside the pipe can reach a temperature around 400 degrees Celsius as the trough focuses sun at 30 to 100 times in its normal intensity, katulad ng nasabi kanina. So this hot fluid goes to water, generating high pressure superheated steam, and this steam then moves turbine to power a generator and produce electricity. So the HTF then keeps circulating within the system. So the steam is being condensed, which is to be sent back through the heat exchangers.
This is general description of heat transfer fluids. In a solar thermal system, heat transfer fluid or HTF is a liquid or a gas specifically manufactured for the purpose of transmitting heat from one system to another. So here's the question. Why use HTF or heat transfer fluid instead of the direct system in which water is instantly turned into steam by the heat reflected by the mirrors in solar thermal system or CSP? The answer is, these working fluids have a high heat capacity. It can maintain a high level of hotness in a long period of time. That is why in CSP, large volume of HTF is heated to an elevated temperature during daytime, where sunlight intensity is at its peak. Then it is being stored in a tight vessel. It acts as as a reserve power that can be used during cloudy days when the sun's intensity is at its lowest or during nighttime where there is totally no presence of sunlight. The heat transfer fluids used in CSP technology includes air, water, molten salts, glycol base, glycerol base, and magnetic oils. The following characteristics are being considered on what type of HTF or heat transfer fluids is to be used in a solar thermal power plant. First one is the operating temperature. Next is the life cycle, heat transfer capability, heat storage aspects, overall safety, and lastly, the cost. So here's the note. The use of molten salt in parabolic trap system can heat the heat transfer fluid or HTF to 550 degrees Celsius, has a better performance than a synthetic oil which can heat the HTF to only 400 degrees Celsius or less.
Solar Tower Working Principle. Setup includes an array of large number computer-controlled sun tracking mirrors known as heliostats. Sunlight can be concentrated as much as 1,500 times its normal intensity. These mirrors moves in dual axis and are located at the ground level, which collects energy from the sun, then reflect it towards a receiver which contains HTF located at the top of the tower. The HTF is being heated at around 600 degrees Celsius, and just like the parabolic trough, this HTF through pipes, it goes to a set of heat exchangers. Then it transfers heat to the water, thereby generating high pressure super steam which is being used to turn as steam turbine. So yung solar tower, kinokonsist siya ng tracking mirrors which is computer controlled. Yung tracking mirrors na to, tinatawag din silang heliostats. These mirrors moves in dual axis. Then, nakalocate din siya sa ground where kumukuha ito ng energy from sun, then re-reflect pabalik sa receiver. Yung receiver na to, meron siyang HTF. Yung HTF na yon ay pinapainit around 600 degrees Celsius. Yung HTF din na to ay dumadaan sa may maraming heat exchangers. Then, it transfers heat to the water na para mag-generate siya ng high pressure na nagpapagana sa may steam turbine.
Linear Fresnel reflector. The design of this type is the combination of parabolic trough and solar tower. This uses flat mirrors instead of parabolic mirrors used in parabolic troughs. These flat mirrors moves in one axis only, unlike solar tower and parabolic dish which moves in two. It adopts the working of solar tower where the mirrors on the ground collects light from the sun and reflects it towards a fixed receiver located above. Previous design generates steam directly without the use of HTF, which are now obsolete. LFR nowadays also uses HTF to generate steam. The classic LFR has only one linear receiver on a single linear tower. To increase optical and ground use efficiency, the improved design called compact linear Fresnel reflectors use multiple receivers for each set of mirrors so that adjacent mirrors have different inclinations in order to target different receivers. So dito sa linear Fresnel reflector, dito naman kasi yung design niya is pinaghalong kagaya ng sa parabolic trough and ng solar tower. Yung type na to ay gumagamit siya ng flat mirrors. Instead ng parabolic mirrors na ginamit sa parabolic trough, hindi kagaya ng parabolic trough at solar tower, yung linear Fresnel reflector, yung mga salamin na ginamit sa kanya ay iisa lang yung ginagalawan. Meron itong fixed receiver wherein yung mga nakukuha niyang energy from the sun is hindi nasasayang dahil nga nakatutok na siya kaagad na yung receiver nakatutok agad siya dun sa pwesto na maaaring mag-bounce yung reflection ng araw. Flat mirrors are used which are cheaper. One big disadvantage with this design is the shading effect of adjacent mirrors, which can be encountered only by utilizing more ground space, which increases cost. Very high temperatures are not produced as compared to a parabolic trough or a solar tower, and therefore, the efficiency is less. So, dito nga dahil flat mirrors yung ginamit wherein it is way more cheaper than the rest na ginamit sa ibang type ng solar uh, solar power plant. Dahil nga cheaper yung ginamit sa kanya, syempre, ini-expect mo na hindi rin ganun kaganda yung mapoproduce niya. Hindi siya nakakapag-produce ng sobrang taas na init o sobrang init dahil nga ang ginamit sa kanya is cheap product.
Parabolic dish. This consists of set of flat mirrors combined to form a large parabolic dishes that is attached to a motor sensor, which track the movement of the sun in dual axis. The collected energy from the sun is being concentrated to the PCU, located at the focal point of the dish. The PCU consists mainly of the thermal receiver and a Stirling engine. The thermal receiver, which is a heat exchanger, transfers its heat to the Stirling engine, causing it to reciprocate. This reciprocating movement causes the rotation of an electrical generator. These dishes can concentrate sunlight much better than parabolic trough, and fluid run through them can reach temperature up to 750 degrees Celsius. Because of the limitations of size and small quantity of fluid, parabolic dish collectors are suitable for small-scale power generators.